Hello, this is the Generally Approachable Sudoku for the 22nd of March 2024. It is a a consecutive pair Sudoku featuring only white crop key dots today. So yeah, let's take a look at the rules. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits separated by a white dot are consecutive. So for example, those two digits are consecutive, and what that means is that they differ by exactly 1. Something like this is valid. This will be valid if you ignore the repeated digit in the column. Something like this will be valid. Yeah, and not all possible dots are necessarily given, so those digits could be consecutive even if there was no white dot between them. So yeah, those are all the rules. With that, let's just begin solving. So I noticed that the digits that are given to us now are just the even digits. Speaking of evens and odds, a cool trick about consecutive pairs is that for any pair of consecutive digits, one of them is going to be odd and the other is going to be even. Now I don't know if that is going to be useful in this puzzle. However, we can do a lot of coloring. Because those are all even digits, we can color them as a certain color, and therefore we can say that every odd digit could be colored orange as a result. And yeah, what I'm noticing now is that in each of these rows and columns, there are exactly 4 of the even digits in that row or column. And from the digits 1 to 9, there are exactly 4 even digits, 2, 4, 6, and 8. Meaning that every other digit in those rows and columns must be odd instead. And yeah, we can start using the trick now and say that, well, because that digit is odd, the digits next to it must be even, because the digits next to it must be 1 more or 1 less than it. And if 2 digits differ by 1, and 1 is odd, the other will have to be even. And so sort of along these lines of digits, we can sort of alternate between parities. Now for this row over here, that last digit has to be odd to make 5 odds and 4 evens. We could probably do the same things for those digits, which all must be even. And because each of these boxes now have 4 evens in them, every other cell in those boxes must be odd. So wow, I can really see this propagating all over the place. That's really interesting. Now we have these streaks over here, which can actually be alternating between odd and even as well. This box already has 5 odds in it, so the remaining digits must be even. And I think that might be all we can do. I think, yeah, because this is 1 odd, 1 even, this is 1 odd, 1 even, same for those as well. Maybe this column we can do stuff. Because we have 5 odds in this column, the rest of the column must be even. But I think that's all we can do, right? Yeah, every single other set over here contains 1 even and 1 odd, the order of which we don't know. So alright, let's start placing in digits, now that we've got the colors down. I think this is really cool actually. So let's start with this row. Those digits must be 2 and 4, because those are the only evens left. Those digits must be 6 and 8. Right, and we can place that digit, because that digit must be between 6 and 8. It must be consecutive to 6, but also consecutive to 8. And the only way that's possible is by being in between them. That digit must also be in between 2 and 4, which gives us 3. Okay. Now what else can we do? I suppose, rather than talking about this being outside a digit, it could be the middle digit between 2 odds, right? So if this was a 2, then this would have to be a 1 to form your consecutive sequence. If it's a 4, this would need to be 5. 3, 4, 5. So this would have to be either 1 or 5, I think. And same for this one. This one would have to be 5 or 9 for similar reasons. Oh, we can actually place all of these on the columns. I didn't even realize that. Yeah, because they are all evens, they're the only evens left in the box. This must be 2, this must be 4, this must be 6, and this must be 8. And we can actually put these down because there are only 2 digits that are consecutive to 8, which are 7 and 9. We can do the same for those digits as well, which must be 5 and 7. Those digits would have to be 3 and 5, and those digits would be 1 and 3. Cool. Right, so now I can place a digit over here. Because of the 1-3 pair, this cannot be a 1. Which means that this digit must be a 4. This digit must be a 2. This digit, well, it could be a 1 or a 3. Because, the sequence doesn't have to be a non-repeating set. This one also, because of the 5-7 pair, must be a 9. That would force this digit to be 8 between them. This would be a 6 therefore, and this could be a 5 or a 7. Now this also forms a pair consisting of 1 and 3. That forms a pair consisting of 7 and 9. 9 in this box must be over here. So that forms a 1-7 pair over here, which does resolve this 1-3 over here. Could probably do the same over here. Yes, because of this 1 now, we can place a 1 over here. That leaves a 3-5 pair here, and this 5 will resolve that for us. Yeah, that should do something. It should. What am I not? It should do something at the very top. Right, this 9 resolves the 7-9 pair, which goes ahead to resolve this 1-7 pair, which does what? Oh no, we've reached a stable point. So generally in these kinds of puzzles where everything's very symmetrical, I generally like to look for something known as a stable point, because if your clues are symmetrical, right, rotationally or vertically or horizontally, what generally happens is that you can produce the same deductions on either side or either corner of the grid. And so generally you can actually form deductions in all 4 corners before you run out. However, if all corners of your grid are equally unresolved, then there is a lot less that you can do in this point. So this is what I call a stable state, because yeah, you need an additional external factor to actually resolve everything here. So yeah. Alright, let's keep going. Oh, I'm just kidding, the 7 resolves the 7-9 pair. I'm so stupid. Alright, this 7 resolves the 7-9 pair. Not a stable state after all. This 7 now goes all the way back in a loop here. This 5 resolves this 3-5 pair, and this 3 resolves this 1-3 pair. I just said the entire statement for exactly nothing. So that's cool. Okay. We can probably continue with the numbers. Like this has to be 1-3-5? No, 1-7-9. And that digit can be a 7. This triple must be 5, 6, and 8. That can be 8. This can be 5 because it must be even, and that can be 6. So we have a hidden chocolate teapot over here. Okay. We can do a lot more triples. Like this one has to be 1, 3, 5. And that can be a 3. Those digits have to be 2, 4, and 9. This can be 2, this can be 4, and this can be 9 because once again even digit. So yeah, see, because of symmetry we can produce the same deductions on either side of the board. Grid, whatever. Now those digits have to be 3, 5, 9, I think. Sorry, not 7, 9. And then we can produce we can do the same thing on either side. 1, 4, and 6. And also, well, not also, but okay. Sorry, let's just keep going here first. I'll talk about it later. This has to be 2, 7, 8. We can remove irrelevant digits from here because these are even. I think this has to be 2, 3, 4, right? Yes, because no, it could be 4, 5. No, wait. Right, because this digit and this digit has to differ by exactly 2, so that the digit in the middle has so that there's one digit in the center. So those digits are either 2, 4 or 6, 8. Yeah, there is no other way to form a pair that are differing by exactly 2. If it's 2, 4, the middle digit is 3, but if it's 6, 8, the middle digit will have to be 7, which doesn't work because we can't put 7 in this cell. So it must be 2, 4 with 3 in the center. What an interesting little deduction. I don't know if that's something. Now this digit must be consecutive to 2 but can't be 3, so it must just be 1. Which really helps out a lot. That must be 3. This now can't be 3, that now can't be 1. But because of the 1, 5 pair here, this must be 3. This can't be 1 anymore. That does something. Okay, let's keep going. This has to be 1, 7, 9. This has to be 2, 3, 8, I think. That digit cannot actually. It can't be 2 or 3, so it must just be 8. which can give us a lot of information about that digit over there. This has to be 4, 5, 6, and this cannot be 4. So yeah, firstly, we can say that 8 must be consecutive to either 7 or 9, so that can't be a 1. But in addition, it cannot be consecutive to 9 either, because 9 requires, this digit rather, requires 2 other digits that are consecutive to it. But 9 doesn't have that freedom. 9 only is consecutive to 1 digit, which is 8. So this must be a 7. And 7 over here means that must be a 6. And following the chain downwards, it has to be 5. And I can in fact follow the chain downwards because digits along this row have to differ, have to be distinct. So you can't repeat digits along a row. So the last digit over there is a 9. That would have to be a 7, which resolves this pair over here. This 5 probably also resolves this, right? Yes, it does. 5 here resolves this chocolate teapot up there. This is 8. That's 5. And I believe something else happens. This 9 resolves this over here. So that's 2, that's 4, that's 9. This is not 4, 6. What did I put here? It's 1, 6, I think. Yeah. Okay, this 7 resolves the 7, 8 pair. Those digits can't be 8 anymore. 3 resolves this 2, 3 pair. Whoa. Alright, and what else? If I have to work with the even digits over here, this digit is the last even digit in its column, it must be 8. That digit similarly must therefore be a 4. Those digits are 2 and 6, and this 2 resolves that, which we can use to finish the rest of the puzzle. This is 1, that's 6. This 1 resolves this 1, 9 pair. And this 9 resolves this 5, 9 pair. And this 5 resolves this 4, 5 pair. Awesome. Solved the puzzle in exactly 11 minutes. Oh, this was fun. I like the idea of coloring first. I don't think you could have gotten very far without the color at all. So yeah. Also, like, the final colors that come out are very nice to look at. It forms this sort of little orb in the center. This it almost looks like a yin-yang symbol. Almost. Yeah. So yeah, that's really cool. Hope you enjoyed this video. I'll see you guys next time. Bye bye.